Hello, Assalamu alaikum. Are you all able to hear me?
Walaikum assalam. Yes, miss. We can hear you.
Okay, is the screen visible to everyone? Today we're going to start off with, we have had one session before regarding practical analysis. Okay, today we're going to further look into the rest of paper 6. Okay, so we're basically going to go through how to decode your questions and what can be asked. Now you basically have to look into each and every dimension in which the examiner can ask you questions. Okay, so starting off, first you should know what apparatuses they are used. I've also sent some of the material earlier as well. I will resend it, reshare it again in the WhatsApp group. So the first one that we're looking into is basically your materials and the variables which are measured. Okay, so measurements are measured using different tools, different apparatuses. Okay, so time is measured using a stopwatch or a stop clock, and it is basically accurate up to 1 to 2 decimal places. You usually measure your time in seconds or your minutes. Okay, and you should remember your conversions when you are answering any particular question. Okay, so let's further. So let's suppose you have recorded that the time in a stopwatch comes out to be 1 minute and 30 seconds, and the examiner asks you to mention the time in seconds, which means that you have to convert that 1 minute and 30 seconds in complete into seconds, which is going to be 1 minute is your 60 seconds. So 60 plus 30 is going to be a total of 90 seconds, which is you're going to mention here, okay, at the end. Let's suppose you have this is some of any candidate mentions 1.30 as the time which is mentioned on the stop clock, which is completely wrong. Okay, if you were mentioning your time in minutes, it is going to be 1.5 minutes, which is 1.5 minutes. Or if you're mentioning the time in seconds, then you have to completely convert into seconds. Okay, then the next variable that you are asked to measure is temperature. Temperature is measured using a thermometer. This thermometer can be a manual thermometer, it could be an alcoholic thermometer, or your digital thermometer temperature probe. Okay, digital temperature probe is much more accurate. So you should know the apparatuses which are used to measure a certain variable, and you should know which one is more accurate and which one has greater accuracy. Okay, while when you're measuring a particular variable. Okay, whether be it mass, be it volumes of liquids, be it temperature, be it any time taken. Okay, so time or temperature is basically measured using the thermometer. This thermometer basically has liquid within it, and this is the glass bulb which has all the liquid. Whenever the temperature is going to rise up, this is going to go through this glass bulb at the top through this column of the liquid, and you will be able to read it through the graduations or through the scale, right? But obviously this is going to involve certain errors. Can you tell me which errors will it involve? This particular thermometer, what errors will it involve, or what is the potential of any particular errors? Yes, Ayan.
Ma'am, one could be parallax error. We
Parallax error.
didn't see the thermometer perpendicular. Yes.
Yes, very good. So parallax errors are developed, or which is basically due to the human error. Okay, when you're reading uh, from a particular apparatus, you might develop a parallax error where the graduations, let's suppose these are the graduations. Okay, the scale is mentioned, and this is up to 1 decimal place. Okay, so any temperature that you're going to mention is going to be like 22.3, all right, or 22.4. Okay, so let's suppose this is the meniscus. If this is the meniscus, you have to read through the bottom of the meniscus. So your eye level, the observer's eye level, has to be at the bottom of the meniscus, okay, not at the top, not at the top of this place, okay, or not at any other angles. All right, let's suppose you have a meniscus which is given to you, and this meniscus is convex at both the edges, okay, at the top and at the bottom as well. Then also you have to read the meniscus at the bottom. You have to read the reading from the bottom of the meniscus to get an accurate reading, okay. This is where the observer's eye is going to be. So if you need to, let's suppose if you want to avoid this kind of an error, you don't want any observer's error in your experiment. So what is the most accurate apparatus to use for reading the same temperature? You can use a digital temperature. Similarly, if you are using a pH, okay, you want to measure a pH value, and you are using a universal indicator, what could be much better or much more accurate as compared to reading a pH value from a universal pH scale? Universal indicator pH scale. Yes. What could be a much more accurate apparatus to use? A pH meter or a pH probe, okay? A pH meter or a pH probe could be much more accurate to use, okay? Is this clear? Yes. So laboratory thermometers, yeah. Any questions? Do we have any questions? Yes, Zoya.
Miss, do we look at the bottom of the meniscus? Like, do we record the values of the bottom of the meniscus even if the cylinder was inverted?
No, 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 no. The bottom of the meniscus, like which, if it's inverted, let's suppose, and by bottom of the meniscus, are you saying that, let's suppose this is your meniscus, okay? You have two readings. Either you can take this reading or this reading. Which one are you talking about? This one, the bottom one?
No, like if we
if it's an inverted, this means all the, let's suppose this inverted measuring cylinder takes the reading of it has collected some volume of gas, okay, gas bubbles have been collected within this space. This is your meniscal reading. All the water has been displaced down, okay, this is all completely water. Then you have these two meniscus which are formed in convex. So you're going to read this, okay, you're going to read this particular value, okay.
Okay.
All right. Then the laboratory thermometers, they basically have a precision of about a half or 1 degree, okay, 0.5 or 1 degree Celsius, okay. And how do we differentiate between accuracy and precision? Yes, what is accuracy and what is precision? Let's suppose I say that you are weighing a substance, okay, and you've got a value of 10.5 grams, let's suppose, okay, and the actual weight of that substance is 10 grams. Then your measurement, is it accurate or is it inaccurate? Yes. Are they accurate or are they inaccurate? If your value comes out to be a mass of a substance you're weighing and it comes out to be 10.5, okay, but the actual weight of it is 10, the value is said to be inaccurate value, okay, it is said to be an inaccurate value. All right, so what happens, let's suppose you have got inaccurate readings from your from the apparatuses that you're using. So any apparatuses which give you inaccurate readings, maybe because of any errors that could be developed, right? Maybe you are looking into this particular thermometer and the thermometer bulb and this column, you're reading the meniscus through this, and you read the value to be 10, maybe 22 point or 37.8, okay, and actually the value is 37.6, all right, or maybe 37. So this means that your value is completely accurate. Maybe it is due to some human error that has developed, or due to the inaccurate or less accurate apparatus that you have used. Okay, how can we make it in, how can we improve this thing? We can use a digital temperature probe, so to have a much more accurate value and to have valid results. Okay, so to not to develop any inaccurate conclusions and anything. Okay, but what is precision? Let's suppose I am measuring a substance and I'm repeating the whole experiment and I'm measuring the same substance. This sometimes the value comes out to be 9.8, sometimes it comes out to be 10.1, sometimes it comes out to be 10. Okay, so this means my measurements, they are actually close to the actual weight. When the values, they are close to the actual weight, they are referred to as your precise measurements. Okay, when they are going to be nearly close to your actual weight, those measurements are recorded, or they are said to be precise measurements. So your precise measurements, it completely depends upon how much how many times you have repeated your experiment, how many times you have repeated your same measurement. So consistently same and reliable measurements, they are said to be precise. Okay, and they give you very valid conclusions if you have precise measurements. Why? Because they are going to be close to your actual value. Okay, is this point clear so far? So accuracy is how close your measurement is to the correct value or to the actual value which is being measured, and precision is how close your measurements are to one another. Is this clear? Is this point clear so far? Yes, give me a yes or no quickly.
Yes, miss.
Okay. Then we have digital temperature probes, which are available, which are much more precise. Their values, they are much more closer to the actual value than the traditional thermometers. They can read to up to 0.1 degrees Celsius. The traditional thermometers, they rely upon uniform expansion and contraction of a liquid substance with temperature. Digital temperature probes, they are more accurate, so as compared to your traditional thermometers, that is your mercury thermometers or your alcohol and glass thermometers. If you compare alcohol and glass thermometers and mercury thermometers, then mercury thermometers, they're much more accurate. Okay, your units of temperature in standard is degree Celsius or Kelvin, and you should know the again the conversion of degree Celsius to Kelvin. Does anyone remember? Yes, anyone remembers? It is basically your degree Celsius is equals to Kelvin minus 273, or you can say Kelvin is equals to degree Celsius plus 273. Okay, both ways are they're exactly the same. So mass is then another measurement which you're going to measure using a digital beam balance or an electronic beam balance. Digital beam balance usually has or gives you reading up to 2 decimal places. These balances, they all must be set to 0. Okay, so you get a completely accurate value. Balances should be allowed to sometimes to settle down, and then you can have your measurement or your repeated measurements. Okay, so masses, their standard unit is basically grams or kilograms. Now it depends upon in chemistry it is usually grams, and it also depends upon the context of the question as well, what the examiner is asking you. If let's suppose they say it's in kilograms, then it is 10 to the power of 3 grams. 1 kilograms is basically 10 to the power of 3 grams. All right, so you also have to convert it. If you are going from a smaller value to a bigger value, you are going to divide it. So divide by 1000. But if you're going from a bigger value to a smaller value, you're going to multiply it. So the multiplying by 1000, okay, to give you the final answer. Moving on to the volumes of the liquid. More volumes of the liquid, they are determined by different pieces of apparatuses, and whatever your choice of apparatus is going to be, it must have a good level of accuracy. When you're going to have a good accurate apparatus, when you're going to choose a good accurate apparatus, then only you will be able to identify correct values, and your results, they are going to be valid results. Okay, so three pieces of apparatuses which are commonly volumetric apparatuses used for measuring the liquid volumes. They are burettes, they are volumetric pipettes, they are measuring cylinders. Okay, other than that you can use flasks. You can also use beakers. This is a beaker. Flask, you have a conical flask. Conical flask looks like a cylindrical cone at the bottom, and you can also use all of these beakers and flasks. They tend to be less accurate, okay, and are usually used for mixing different substances. This one is a round bottom flask, and this one is going to be a flat bottom flask. Okay, then other than this, you also have funnels, which are used to add in any substance, any liquid volume. Okay, so this is a burette, this is a measuring cylinder, this is a pipette filler, this is a volumetric pipette. Okay, this pipette filler is basically a bulb, just like a dropper. If you have seen a dropper, at the top of the dropper, a bulb is present, right? A bulb is present. When you are going to press this bulb, all the liquid is going to suck in, and whatever the capacity of your apparatus or your dropper is, all the liquid volume will be collected with this. Similarly, pipette filler is also, the use of the pipette filler is the same. You attach this rubber pipette filler at the top, and you then press it, so all the liquid volume is then sucked up into this volumetric pipette. And this volumetric pipettes, they have a fixed volume, so they can only measure accurate volumes, but only fixed volumes of liquid. Let's suppose it's 20 centimeter cube, or maybe 25 centimeter cube of liquid. So if I say you have 22.3 centimeter cube of a liquid volume, which apparatus are you going to use? Can you use a pipette for measuring 22.3 centimeter cube? Can we use a pipette to measure 22.3 centimeter cube? Yes, Ayan.
No, miss.
No, why?
Because it can only suck up, the fixed volumes to the
Fixed
whole
volume.
number.
Yes,
Yes.
and what is this volume referred to as? इसको क्या कहते हैं?
This is a variable.
Variable volume. Okay, this is a variable volume of liquid. Okay, so variable volumes of liquid, if you want to measure, and you have been given an options, let's suppose if it's an MCQ paper and you've been given our options, which apparatuses will you be using? Will you be using a volumetric pipette, or a measuring cylinder, or a burette? Then your answer will be, most accurate piece of apparatus to use is burette. Okay, for variable volumes. A greater accuracy is with burette, less accurate is measuring cylinder, more accurate is burette and pipette. Okay, but for fixed volumes you can use pipette. This is, yeah, also you can say this is a disadvantage of pipette, that you can only measure fixed volumes of liquid with pipette. But if you want to have or measure variable volumes of liquid, then you can use burette or measuring cylinder, but more accurate will be burette, okay, to use. So burettes, they usually have a variable volume of liquid. You can measure 0 to 50 centimeter cube, and 0 lies at the top. Okay, 0 lies at the top, and you have to place a funnel to pour in any liquid. Okay, you have to place a funnel to pour in any amount of liquid. The significance of these alternatives to practicals are that you don't actually have to demonstrate a practical, right? So because demonstrative a practical actually requires going through all of those skills. You should know how to do and how to perform in an experiment, and going through and developing those, upskilling yourself, right? So you're going to place a funnel at the top, but in A level chemistry, you're going to do practicals. So at the top, you're going to place your funnel, and within the through this funnel, you're going to add in any liquid. Your knob at this burette should be closed at that time. And then when you go filled, yeah, this completely, this is all filled, then you should take off and take it out your funnel. Okay, so this burette is from 0, and the bottom part is going to be your 50. Okay, so then moving on. So you always start to read your volumes from the top. Okay, any change in volumes that you're going to read, they are going to be from the top. Okay, then you have volumetric pipettes, which are most accurate way of measuring the fixed volumes of liquid. They have a scratch mark on the neck, which is matched to the bottom of the meniscus to make the measurement. Basically, this looks like, if you are able to view, there's a small line over here. This small basic line or a scratch mark basically tells you that this is the line till where you will be able to suck up only the fixed amount of liquid, whatever it is. Let's suppose this pipette can fill up to 20 centimeter cube of the liquid, then only 20 centimeter cube of the liquid can be filled into this. Usually the common volumetric pipettes, they can carry up to 10 centimeter cube also, 20 centimeter cube also, and 25 centimeter cube also. Okay, and then you have measuring cylinders. Measuring cylinders, they have less accuracy as compared to the rest, and they can also typically range from 10 centimeter cube of a measuring cylinder to even 1000 centimeter cube of a volume. Okay, 1000 ml 1000 ml is equals to 1 liter or 1 decimeter cube, and 1 decimeter cube is equals to 1 liter. Okay, remember this. So any conversions will be based upon this. All right, let's go through one of these questions. Okay, so this question here says that you have a paragraph. Are you able to view this question here?
Yes, ma'am.
Okay, you have a paragraph which is taken from a student's notebook, which says to make potassium chloride, you have 25 centimeter cube of aqueous potassium hydroxide, which was placed in a flask. And then a few drops of indicator they are added to this. Dilute HCl is then added to this flask until the indicator is going to change its color. The volume of the acid which is used to neutralize this potassium hydroxide is 19 centimeter cube. So which piece of apparatus would you think would be used to measure the amount of aqueous potassium hydroxide, which is 25 centimeter cube, to measure this much amount of volume? Of aqueous potassium hydroxide. What apparatus are you going to use? Yes. You can simply unmute yourself and then tell me the answer. Yes, Ayan.
Ma'am, pipette,
Pipette will be
because
used.
it's a fixed volume,
It
25
is a fixed
centimeter.
volume. Yes.
Yes.
And if I ask you, how are you going to measure the volume of this acid, which is 19 centimeter cube?
We can use burettes.
Burette. You can use a burette. Okay, and this volume of the acid will be, this means that you have to fill your burette with the acid, and your pipette will be used to fill up 25 centimeter cube of the potassium hydroxide. And then you're going to add your potassium hydroxide, which is a fixed volume, non-fixed volume, into this conical flask. And then from the burette, you're going to add in your titrant. Okay, and then you're going to titrate this, okay, to undergo the process of titration. Now the next question here says, which solution do you think is more concentrated? Explain your answer. I think one of the previous questions that we were looking into. Yes, Zoya.
Miss, why can't we use a pipette to measure the 19 centimeter cube of acid?
Because pipettes usually they are either 10 centimeter cube or 20 centimeter cube or 25 centimeter. So it is a variable volume again. Pipette can either it can take a whole volume of liquid of up to 20 centimeter cube, or it won't be able to measure any other. Why? Because pipette only has one particular mark. This mark is 20 centimeter cube mark. This mark right here is basically your 20 centimeter cube mark. All right. There are no further graduations. How are you going to measure the rest? Let's suppose if it's 19. So it's going to be somewhere here maybe. Okay. How are you going to measure this? There are no other graduations which are present on this pipette, on the apparatus. Are you getting my point?
Yes.
Okay. So, which is why this is going to be again considered in a variable volume. It does not mean, ऐसा इसका मतलब ये नहीं है कि अगर मैं कहूँ कि 19.2 है या कोई डेसिमल्स में कोई आपके पास वॉल्यूम्स हैं तो सिर्फ वही वेरिएबल वॉल्यूम्स हैं, नहीं। जो जो पिपेट होते हैं वो ऐसा एपरेटस है कि वो जितना वॉल्यूम उसकी कैपेसिटी है सिर्फ वो उतना ही फिल कर सकता है। जब वो उतना ही फिल कर सकता है तो वो सिर्फ उतनी ही क्वांटिटी मेजर कर सकता है, उसके अलावा वो और कोई और क्वांटिटी मेजर नहीं कर सकता। फॉर इंस्टेंस अगर आपके पास जो है वो एक पिपेट है, उसके ऊपर एक मार्क है और वो जो है वो 10 सेंटीमीटर क्यूब का मार्क है, तो डेफिनेटली आप उसको यूज नहीं करोगे टू मेजर दिस 25 सेंटीमीटर क्यूब ऑफ पोटेशियम हाइड्रोक्साइड। ठीक है, आप जो है वो 25 सेंटीमीटर क्यूब वाले ही मार्क पिपेट को यूज करेंगे टू गेट टू नो व्हाट इज द अमाउंट ऑफ और टू फिल अप दैट एंड मेजर दैट क्वांटिटी। ठीक है, लेकिन अगर आपके पास 20 सेंटीमीटर क्यूब है या 24 सेंटीमीटर क्यूब है या इवन 24.2 है सेंटीमीटर क्यूब, तो फिर आप पिपेट से नहीं उसको मेजर कर सकते, क्योंकि पिपेट के ऊपर कोई ग्रेजुएशन ही नहीं है जिसको आप जिसको देख के आप मेजर कर सकते हैं। इज दिस पॉइंट क्लियर?
Yes.
Okay, let's suppose the amount of the acid which is required to neutralize this complete 25 centimeter cube of KOH is basically 25 centimeter, is 19 centimeter cube. ठीक है, so 19 centimeter cube जो है, अब वो ये पूछ रहे हैं आपसे कि which solution is more concentrated? Is this more concentrated or the acid is more concentrated? अब ये हमेशा याद रखिएगा कि जिसका वॉल्यूम कम यूटिलाइज होता है to completely neutralize the other substance, इसका मतलब है कि ये ज्यादा concentrated है, ये ज्यादा concentrated solution है, इसलिए इसका आपको कम वॉल्यूम यूज हुआ है to neutralize the KOH। क्यों? क्योंकि if you remember, hydrogen ions, they are present in the hydrochloric acid, which are going to completely neutralize with the hydroxide ions, and then they are going to produce your water molecule. Okay? And if you remember the equation says that 1 mole of water, the hydrogen ions, they are going to react with 1 mole of hydroxide to produce 1 mole of water molecule. Okay? So hydrogen ions की concentration जब हाइड्रोक्साइड आयंस की कॉन्सेंट्रेशन के बिल्कुल इक्वलेंट हो जाएगी, ठीक है, द कॉन्सेंट्रेशन ऑफ द हाइड्रोजन आयंस when it is completely equivalent to concentration of hydroxide ions, then only we are going to say that endpoint titration is reached, because that is the point where neutralization of this titration has taken place, where neutralization is completely conducted, it is complete. Okay, so water molecule is produced, now the pH is completely 7, ठीक है, तब आप stop करोगे अपने burette को, ठीक है, then you're not going to pour in more of the acid, because if you continue to pour in more of the acid, then it is going to completely change the whole case scenario. Either of these will be in greater concentration. तो जिस टाइम पे आपका इंडिकेटर कंप्लीटली, योर सिंथेटिक इंडिकेटर स्पेसिफिकली, वी डोंट यूज यूनिवर्सल इंडिकेटर्स, वी डोंट यूज लिटमस इंडिकेटर्स, व्हाई? बिकॉज दे गिव यू ग्रेजुअल कलर चेंज, उनका कलर चेंज होता है वो स्लो कलर चेंज होता है, उनका ग्रेजुअल कलर चेंज नहीं होता, तो इसलिए आप यूनिवर्सल इंडिकेटर और लिटमस इंडिकेटर टाइट्रेशन में यूज नहीं करते, दे आर नॉट प्रेफरेबल चॉइसेस। योर प्रेफरेबल चॉइसेस दे आर योर सिंथेटिक इंडिकेटर्स लाइक थाइमोफ्थिलीन, फेनोफ्थिलीन और योर मिथाइल ऑरेंज, मिथाइल रेड, ठीक है, मिथाइल ब्लू। अच्छा, जिस टाइम पे आपके पास एंड पॉइंट टाइट्रेशन होती है, कॉन्सेंट्रेशन ऑफ हाइड्रोजन आयंस कंप्लीटली मैचेस द कॉन्सेंट्रेशन ऑफ द हाइड्रोक्साइड आयन, तो किस टाइम पे दोनों की कॉन्सेंट्रेशन मैच करेंगी? जब आपके पास दोनों के नंबर ऑफ मोल्स इक्वल हो जाएंगे, ठीक है, क्योंकि आपके पास वॉल्यूम्स यहाँ पे डिफरेंट है, और जिसका वॉल्यूम आपके पास कम है, ठीक है, जिसका लेस वॉल्यूम यूटिलाइज हो रहा है, तो कंप्लीटली titrate with the other hydroxide ions concentration, इसका मतलब है कि ये ज्यादा concentrated है, ये ज्यादा concentrated solution था, इसलिए जो है इसका कम वॉल्यूम यूटिलाइज हुआ है टू कंप्लीटली न्यूट्रलाइज दिस मच वॉल्यूम ऑफ और 25 सेंटीमीटर क्यूब ऑफ द एल्कली. इज दिस पॉइंट क्लियर सो फार? और अगर आप इक्वेशन में देखते हैं और आपके कॉन्टेक्स्ट ऑफ द क्वेश्चन में मेंशन है कि दिस रिक्वायर्स मे बी 32 सेंटीमीटर क्यूब ऑफ द वॉल्यूम ऑफ द एसिड टू completely neutralize 25 सेंटीमीटर क्यूब ऑफ द alkali, तो इसका क्या मतलब है कि ये एसिड आपका क्या हो गया, डाइल्यूट हो गया. इसकी कॉन्सेंट्रेशन क्या हो गई, जो भी चीज डाइल्यूट होगी उसकी कॉन्सेंट्रेशन क्या हो जाएगी, अल्टीमेटली लेस हो जाएगी. ठीक है, तो इसका मतलब ये लेस कॉन्सेंट्रेटेड एसिड है आपका, ज्यादा वॉल्यूम चाहिए आपको to completely neutralize your alkali. Is this point clear so far? Yes. Up till now? Okay, up till now no questions, right? Okay, look into this one here. This question says you have अच्छा पहले इसका हम थोड़ा सा context पढ़ लें, फिर इस question के ऊपर आते हैं. So we've got volumes of gases. Other than volumes of liquids, we also measure volumes of gases. We can measure volumes of gases by using different pieces of apparatuses and also different methods. Okay. So what you can do is you can either use a simple gas syringe, which is a very accurate way of measuring your volumes of gas. But what is the disadvantage of using a gas syringe? Can someone tell me? What is the disadvantage of using a gas syringe? Yes. एक तो बता दें सिर्फ.
Miss,
Cyan, yes, cyan.
I think some gas could escape because there is a bunk
You're
which
telling
is
the
fixed.
disadvantages?
Yes, I'm telling that it's
Okay, yeah.
कि हो सकता है जो बंक प्लेस हुआ होता है वो ऑन द फ्लास्क, हो सकता है कुछ गैस एस्केप कर ले वहां से, तो
जहाँ
दिस
पे
कुड बी
बंक
अ
प्लेस्ड होता
डिसएडवांटेज.
है, जहाँ पे
जी.
बंक बंक प्लेस्ड होता है, तो गैस सिरिंज का इटसेल्फ apparatus का डिसएडवांटेज क्या है?
एक्सपेंसिव.
हाँ, एक्सपेंसिव है. हाँ हाँ, ठीक है.
अच्छा
और
अच्छा. हम्म.
is it easy to set up or is it difficult to set up?
डिफिकल्ट.
नहीं, easy to set up है ना.
इजी तो यस इजी.
आपने सिर्फ उसको you just have to place and you just have to connect your delivery tube to the
यस यस.
gas syringe. Okay. अच्छा, तो
हाँ.
this is an advantage of using a gas syringe. Gas syringes, they are very precise, they are very accurate. आपको जो volumes जो measure वो करेंगी वो बिल्कुल precise volume measurements होंगी. ठीक है. अच्छा, is there any other advantage of gas syringe? It keeps all the volume of gas completely dry. वो मिक्स ही नहीं होने देगी किसी भी वाटर मॉलिक्यूल के साथ. ठीक है. सो ऑल योर गैस व्हिच इज कलेक्टेड, इट इज कंप्लीटली ड्राई, इट इज प्योर वॉल्यूम ऑफ गैस व्हिच इज कलेक्टेड विद इन द गैस सिरिंज. एनी अदर नाउ दीज वर द एडवांटेजेस. ठीक है. डिसएडवांटेजेस एक हमने बोला कि ये एक्सपेंसिव है. ठीक है. और gas syringes, they are also delicate. Some of the gas syringes, they are so delicate that you can maybe break it apart. ठीक है. अच्छा, इसका एक पर्टिकुलर वॉल्यूम है. लेट्स सपोज you want to measure 50 centimeter cube of a gas, but the capacity of the gas syringe is 30 centimeter cube. So this is another potential disadvantage here, that you have to stick to and you have limitations that you have to look into the volume of the gas syringe as well, the capacity of the gas syringe. Let's suppose if the capacity of the gas syringe is 30 centimeter cube and the volume of the gas which is being produced is approximately 50 centimeter cube, then you cannot use that gas syringe to measure it. Okay. Then the pistons, they sometimes they get stuck. The pistons of the within the gas syringe, they sometimes they get stuck into this gas syringe, making it difficult to read any or measure any readings of the volume of gas. Okay, is this point clear so far to everyone? So all of these, they're basically your disadvantages. These are the graduations on the gas syringe, which you can easily read. So making it very easy it is easily readable, your volumes, the precise measurements, it is very accurate as well. So gas syringe is much more precise, it is much more accurate than as compared to the displacement of water method. Okay. Now, what is displacement by water
मैम
method? Yeah.
बस सॉरी, बस एक और चीज हो सकता है कि ये जो सिरिंज का जो प्लंजर होता है ये इसलिए तो मूव करता है क्योंकि गैस की वॉल्यूम और गैस की प्रेशर की वजह से ये
बिल्कुल
कलेक्ट हो
गैस
रही
की
होती है ना।
प्रेशर की वजह से।
तो हो ऐसा सकता है कि लाइक अगर प्लंजर मे नॉट बी फ्री मूविंग, लाइक वो स्टक हो जाए, कैन दिस बी एन डिसएडवांटेज और नो?
Yes, this is what I told now. That
अच्छा
if
अच्छा
the plunger or the piston, this piston or plunger, if it gets stuck, then this could be a
ओके ओके
disadvantage of this of the same. Okay.
ओके सो
So
वी पुट lubricants or something?
no, you do never put lubricants or something. You just switch and take another gas syringe. Just use another
Okay,
gas syringe. Okay. So plungers of
okay,
the syringes, they can the gas syringes, they can get stuck, and they sometimes they have limited volume of capacity, and you have to measure very large volumes of gas. So फिर उस case scenario में, this is not an ideal apparatus to use, and they are delicate and they are also expensive, so you have to very carefully handle it. Okay. Then the other method of measuring the volumes of gas is displacement of water method. Now displacement of water method is that you must have seen that a gas is basically being produced, then it is going to go through this delivery tube into the trough of water. This is your trough of water, and then you have an inverted measuring cylinder. Okay. So this delivery tube then goes into this inverted measuring cylinder, and this is going to displace all the water downwards, and all of the gaseous volume will be collected onto this. So any change in this volume or displacement of water will be seen or observed, and it is then calculated. So final minus initial, and then you're going to calculate any differences in this to find out how much volume of gas is basically being produced. तो एक ये मेथड है आपके पास which is referred to as your downward displacement method. लेकिन इस मेथड से ज्यादा एक्यूरेट आपके पास क्या है, गैस सिरिंज. अगर आपके पास गैस सिरिंज है then you're going to use that. इस मेथड का डिसएडवांटेज क्या है? एक तो सेटअप करने में भी मुश्किल है. ठीक है, आपको पूरा डिलीवरी ट्यूब यहाँ से लगानी है, देन यू आल्सो हैव टू प्लेस trough of water. You also will need to clamp your inverted measuring cylinder, वरना this can topple over, right? So you need to this is a complex setup. Okay. Then any gases, this is not going to keep your your gas completely dry. This is going to keep your gas completely dry. So any water molecules, they can also react with, partially maybe they can react with this gas, and this is completely not at all ideal for collection of those gases which can be absorbed in water. अगर कोई ऐसी गैस है जो कलेक्ट हो रही है इसके अंदर और वो completely absorbable है, it is completely soluble in water, so you cannot use this method of displacement. Okay, this downward displacement of water to collect the volume of gas. Are we clear?
yes ma'am.
Other than this, you have other methods where you can collect the gases. One is downward delivery method and the other one is upward delivery method. Okay. So upward delivery method is for those gases which are less dense than air. Okay. So if it's less dense than air, then it is collected by upward delivery method. And the one which is more dense than air, it is collected usually by downward delivery method. Okay. Let's look into this question right here. This question here says you have sulfur dioxide gas, which is basically dense in than air, and it is soluble in water as well. Okay. So sulfur dioxide gas is denser than air. It is also soluble in water. And they say that if you are reading the context of the question, and let's suppose you are using a pencil, and just underline those things which you think that they're important. Okay, just using a pencil on the question paper. This is going to help you with the further when you're going to look into the rest of the question. A sample of sulfur dioxide can be prepared by adding dilute hydrochloric acid to sodium sulfide and warming up the mixture. Study the diagram of the apparatus which is used. Fill in the boxes to show which chemicals were used. So which chemical will be placed here and which chemical is going to be placed here? Yes, anybody. आपके पास ऊपर टैप फनल में क्या होगा और आपके पास नीचे राउंड बॉटम क्लास में क्या होगा? Yes, Zoya.
Hydrochloric acid will be on the top of the. Is this a burette?
No, this is not a burette. This is a tap funnel.
Okay. So HCl will be present in that.
Yes, so hydrochloric acid is added here. Also, if you look into your complete diagram, you are able to identify this is some sort of a liquid, right? Whereas this substance which is added into the flask is a powdered form of a substance, which is going to be your sodium sulfide. Okay, so you're going to mention that this is sodium sulfide. Okay, the next one says that you have. Okay, can someone tell me what is wrong with this complete experimental setup?
Ma'am, can I tell?
Yes, yes, I am.
वो उन लोगों ने inverted cylinder use कर लिया, हालांकि sulfur dioxide gas is much denser than it. They
They are
should
dense.
use a downward one. Yes.
Yes, this is not a cylinder. अच्छा जो measuring
जी sorry.
cylinder होता है,
Yeah. नहीं नहीं
ये जो है
वो
ना
beaker.
होगा वैसे आपका, हाँ, ये तो ये टेस्ट ट्यूब होगी या बॉइलिंग
Yes.
टेस्ट ट्यूब होगी आपके पास, ठीक है।
जी जी.
इसके अंदर आपको क्या यूज करना चाहिए था? आपको यूज करना चाहिए था एक डाउनवर्ड डिलीवरी मेथड टू कलेक्ट दिस सल्फर डाइऑक्साइड गैस। क्यों? क्योंकि उन्होंने मेंशन किया हुआ है दैट इट इज मच डेंसर देन एयर, so if it's denser than air then you have to collect it as a downward delivery. Anything else which is wrong with this apparatus? Yes. Who is it?
The
Yeah.
delivery tube that they set up, like the sulfur dioxide gas is soluble in water, so the gas will be dissolved in the water, so none of them will go.
Yes, exactly. So you shouldn't be placing any test tube which has water in it. Okay. So this delivery tube needs to be directly connected to as a downward delivery method, and all the gas would be placed as a downward delivery method here because it is much denser than air and also soluble in water. So you shouldn't be placing any of this tube which contains water here. Okay. So this is the disadvantage of this particular experimental setup. Then moving on furthermore, so I think some of the things they are clear to you by far. Any questions?
Miss, can you re-explain accuracy? I understood the precision, but
The accuracy?
yeah.
Okay, accuracy is, for example, I say that you have a gas syringe and you have to measure this volume of gas syringe. The accuracy, the measurement that the actual measurement is 10 centimeter cube, but you measured the volume up to 9.8. So is this accurate volume or is this inaccurate volume? Yes, Zoya.
It's inaccurate.
This is inaccurate. Okay. So if your value is not aligning with the accurate volume, okay, your value is going to be an inaccurate value. Okay. So this is what accuracy is about. All right. That you are looking into your values, and if your value is like the set of measurement that you are taking. Maybe you are repeating the experiments, and if that experiments, if the repeated experiments, they all align with your accurate value, with your true value, with the actual value, okay, then you're going to say that this apparatus is the accurate piece of apparatus to use. Okay, let's suppose if you have let's suppose I say you have to collect a volume which is 10 centimeter cube of the liquid volume, but you are using a measuring cylinder which is 100 centimeter cube of a measuring cylinder. Will it be precise? Will your measurement be precise and accurate?
No.
No, your precision is not, it is going to completely be impaired. Okay, it is an impaired precision. ठीक है, आपकी जो value है, it is not going to be so close to your accurate value. ठीक है, your even if you repeatedly use this, okay, आपका जो 10 centimeter cube है वो यहाँ पर आएगा, let's suppose, ठीक है, और आपका जो 20 सेंटीमीटर क्यूब है वो यहाँ पर आएगा, क्योंकि ये पूरा जो वॉल्यूम ऑफ ये जो पूरा कैपेसिटी है वो है ही 100 सेंटीमीटर क्यूब की। तो क्या चाहिए मुझे, क्या करना चाहिए मुझे, यूज करना चाहिए एक ऐसा एपरेटस, इस एक ऐसा मेजरिंग सिलेंडर जिसकी कैपेसिटी हो 10 सेंटीमीटर क्यूब की। हमारे पास, मैंने आपको क्या बताया कि आपके पास जो मेजरिंग सिलेंडर्स हैं वो 10 सेंटीमीटर क्यूब से लेकर 1000 सेंटीमीटर क्यूब तक कैपेसिटी रखते हैं। ठीक है, तो आपको अपना एपरेटस चेंज करना चाहिए एंड यू शुड गो टू सच एन एपरेटस व्हिच इज एबल टू मेजर द वॉल्यूम ऑफ अप टू 10 सेंटीमीटर। यहाँ पे आपका पास एपरेटस भी एक्यूरेट हो जाएगा और प्रिसिशन भी एक्यूरेट हो जाएगी। इट इज गोइंग टू बी मच क्लोजर टू योर एक्चुअल वैल्यू। यहाँ पे आप इसको प्रिसाइजली मेजर ही नहीं कर सकेंगी इवन इफ यू रिपीट योर एक्सपेरिमेंट्स। क्लियर?
Yes, thank you.
Okay. So, so this is your way of how you measure your volume of a gas by using a gas syringe. Okay, you place a bung or a stopper here. This is your conical flask, and this is your complete reaction, which is taking place. Okay, the next one is your measuring cylinder or a graduated cylinder. This is usually clamped with a stand, okay, because this can topple over. So this is a complex setup to go through with, and this does not work with any gases which are soluble in water. If supposedly you have a gas which is soluble in water, you cannot use this apparatus. What are you going to use then? This one you are going to use. Let's suppose the examiner says to us, and he says that mention any diagrams in your and plan an investigation and all. So it is better that if you have time, mention a diagram, so it facilitates your examiner and lets the examiner know what you actually are aware about. Okay, so if the gas happens to be heavier than air and it is colored, then the cylinder does not need to be inverted. ये इतना important नहीं है आप लोगों के लिए। अच्छा, moving on to the disadvantages and the advantages, ये हमने discuss कर लिया है। I'll be sharing this PDF. जो है, let's move on further on. Yeah, now planning the experiments. ये हमने जो है ना पहले भी हमने जी जी
just one thing. Yeah, लिखा हुआ the syringe can stick. Is it the same thing which we mentioned earlier कि वो जो plunger है वो वाला?
बिल्कुल बिल्कुल वो same exactly. Okay.
ठीक।
All right, moving on to planning your investigation. अब आपने प्लान किस तरीके से करना है, आपने पहले जो है वो context of the question को रीड करना है। ठीक है, आप जब अपना context of the question रीड करेंगे उसके बाद आपको पता चलेगा कि what variables they are trying to ask. Okay, after looking into all the variables, फिर उसके बाद आप डिवाइस करेंगे अपना जो भी आपकी इन्वेस्टिगेशन है। ठीक है, अच्छा, जब भी आप को पता चल जाए कि आपके पास कौन से वेरिएबल्स हैं, या तो आपके पास वेरिएबल होगा एक डिपेंडेंट वेरिएबल। ठीक है, डिपेंडेंट वेरिएबल और इंडिपेंडेंट वेरिएबल में क्या फर्क है? व्हाट इज द डिफरेंस बिटवीन डिपेंडेंट वेरिएबल एंड इंडिपेंडेंट वेरिएबल? जी जी जोया, यस जोया।
Independent variable is the variable that you change. Independent variable is the one that you measure.
Yes, so independent variable is the one that the observer is actually changing and is trying to have a look at how is this independent variable going to impact this dependent variable. Okay, let's suppose I am changing the temperature okay, of a particular reaction mixture, and I'm trying to look into how the change of temperature affects the rate of a reaction, okay. So I'm trying to have a connection or a correlation between change of temperature and your rate of reaction, or maybe surface area and the rate of reaction, okay, or maybe concentration and the rate of reaction. So any changes that are made by the observer to one particular variable, that is going to be an independent variable. आपका हमेशा इंडिपेंडेंट वेरिएबल कहाँ पर लाई करता है, ऑन योर एक्स एक्सिस लाई करता है, ठीक है, इसको ऐसे याद करना है आपने. दिस इज योर इंडिपेंडेंट वेरिएबल, दिस इज योर डिपेंडेंट वेरिएबल, ठीक है. तो आपका वाई एक्सिस पे हमेशा क्या होगा, डिपेंडेंट वेरिएबल होगा, इंडिपेंडेंट वेरिएबल आपका हमेशा एक्स एक्सिस के ऊपर होगा, ठीक है. दिस इज द वन दैट यू आर चेंजिंग. जो भी रिजल्ट, जो भी कोरिलेशन होगा या जो भी इम्पैक्ट होगा वो किसके ऊपर होगा, रेट ऑफ रिएक्शन के ऊपर. अब जो acquired knowledge that you have already gained, okay, from your throughout the whole syllabus, उस पे आपने hypothesis create करनी है, ठीक है. Hypothesis is your prediction, ठीक है. Let's suppose I say you are increasing the temperature, okay. How does it impact the rate of the reaction? Tell me. According to the particle collision theory or according to whatever your acquired knowledge is, if you increase the temperature of the reaction mixture, how does it impact the rate of the reaction? Yes, yes, Ayan.
Ma'am, can you repeat the question?
The question is, if I'm increasing the temperature of the reaction mixture, how this will affect the rate of the reaction?
Ma'am, it will increase.
The rate of reaction is going to increase. Okay, so this is your hypothesis. This is your prediction. Okay, this you have to mention in your investigation, in your whole method, in your whole planning, how you planning an investigation. So you're going to plan an investigation where you're going to say that I'm increasing the temperature. You don't use personal pronouns, but I'm just trying to mention that you're going to repeat the experiment with the increasing temperatures. Okay, let's suppose you take 10 degrees Celsius for the first one, then 20 degrees Celsius for the next one, 30 degrees Celsius, 40, 50. You have to mention कहाँ तक जाएंगे आप, ठीक है. 10 से लेकर 10 डिग्री सेल्सियस तक से लेकर आप कहाँ तक जाएंगे, मैक्सिमम इंटरवल आपका कितना होगा, 50 डिग्री सेल्सियस, ठीक है. सो आप मेंशन करेंगे 10 होगा, फिर आपका 20 होगा, फिर 30 होगा, फिर 40 होगा, फिर 50 होगा, ठीक है. अच्छा, इसके ऊपर अभी हम मजीद आते हैं, मैंने एक और चीज भी इस पर डिस्कस करनी है. अब आपका हाइपोथेसिस, आपका प्रेडिक्शन क्या है? आपका प्रेडिक्शन ये है कि जब आप टेम्परेचर इंक्रीज करते हैं तो रेट ऑफ रिएक्शन भी इंक्रीज होता है. आपका डायरेक्ट रिलेशन है आपके पास. अब आपने टेम्परेचर किससे मेजर किया है, दोनों चीजें आपने मेंशन करनी है, ठीक है. आप रेट ऑफ रिएक्शन मेजर कर रहे हो, तो रेट ऑफ रिएक्शन आप कैसे मेजर करेंगे? Let's suppose you have magnesium which is reacting with hydrochloric acid, dilute warm hydrochloric acid, and magnesium ribbon. Yes, Zoya.
We can measure the amount of hydrogen being produced by gas syringe.
Exactly, by the volume of the hydrogen gas which is produced, because when metals they react with acids, what do they produce? They produce a salt solution, and they produce a salt and hydrogen gas. Okay, so the hydrogen gas which is produced or the product which is evolved, इसके वॉल्यूम आप मेजर करोगे, ठीक है. तो आपने मेंशन करना है कि what suitable apparatuses will you be using. Are your apparatuses which you are choosing, are they accurate pieces of apparatuses? What are you going to use to measure your volume of the gas which is produced? Are you using the downward displacement method to measure the volume of the gas, and then you're going to take out the change in the final volume, or are you using your volume of gas to measure the volume of gas? Are you using a gas syringe? Okay, how you are measuring your time taken? You're using a stopwatch or you're using a stop clock. As soon as you add in the magnesium ribbon into your conical flask, into the dilute warm acid, at that same time you're going to start your stop clock. Okay, you're not going to waste any time. Okay, so is it going to give me results in an appropriate time frame? So what time frame are you choosing? Are you choosing a limited time frame कि जैसे आपने जो है वो 30 seconds के लिए आपने choose किया है, सही है. Let's suppose मैं कहती हूँ कि आप जो है वो time frame नहीं, पूरा completion of experiment तक नहीं देखते, आपने एक लिमिटेड टाइम फ्रेम चूज कर लिया, ठीक है. आप कहते हैं कि 30 सेकेंड्स के अंदर आपका एक्सपेरिमेंट जो है वो कंप्लीट हो या ना हो. मैं अपने रीडिंग्स जो है वो 30 सेकेंड्स तक लूंगा या लूंगी, ठीक है. तो आप रिपीट करोगे अपना एक्सपेरिमेंट. फर्स्ट एक्सपेरिमेंट आपने अपना जो है वो 10 सेकंड के ले लिया, 10 डिग्री सेल्सियस के ले लिया. सेकंड एक्सपेरिमेंट आपने जो है वो 20 डिग्री सेल्सियस के ले लिया, ठीक है. सो यू हैव वार्म योर डाइल्यूट हाइड्रोक्लोरिक एसिड and the same volume and same concentration of hydrochloric acid, but at 20 degree Celsius. Rest of all the factors should be the same. जब आप एक चीज को मेजर कर रहे होते हैं, एक चीज का हाइपोथेसिस देख रहे होते हैं और रिलेशन क्रिएट कर रहे होते हैं, तो फिर आप सिर्फ इसी इंडिपेंडेंट वेरिएबल को चेंज करेंगे. सिर्फ टेम्परेचर चेंज होगा, बाकी सारी चीजें सेम रहेंगी, ठीक है. बाकी हर एक एक चीज आपकी सेम रहेगी. आपका वॉल्यूम ऑफ एसिड सेम रहेगा, mass of magnesium ribbon which you are using, surface area of magnesium ribbon which you are using, ठीक है. Your piece of apparatuses which you are using, ठीक है. Everything else is going to stay the same. All right, are we clear by far? Yes, Zoya.
Do we measure our do we state our hypothesis at the start of the experiment or at the end?
Oh, at the end of the experiment. Okay, you keep the hypothesis in your mind, okay, in your mind map, but you never state the hypothesis in the start. You have to restate your hypothesis in the conclusion at the end of the experiment. Okay?
Okay.
All right. Acha. Then the next one is you have to keep in mind whether you are your method, your experimental design, is it giving you enough results to analyze your conclusions? जैसे for example, एक student है, वो कहता है कि मैं ना 2 ही रीडिंग्स लूंगा, 2 ही एक्सपेरिमेंट्स कंडक्ट करूंगा, एक 10 डिग्री सेल्सियस पे, एक 20 डिग्री सेल्सियस पे, ठीक है. और मैं मजीद जो है वो जो भी मैंने अपनी एनालिसिस लेनी है, कंक्लूजन्स ड्रॉ करनी है, वो मैंने इन्हीं दोनों टेम्परेचर्स के ऊपर इन 2 एक्सपेरिमेंट से ड्रॉ करनी है. एंड आई एम नॉट गोइंग टू टेक. बट देयर इज वन मोर स्टूडेंट, दिस इज स्टूडेंट 1. अनदर स्टूडेंट टेक्स 5 डिफरेंट रिपीटेड एक्सपेरिमेंट्स, ठीक है. और वो 10 पे भी रिपीट करता है, 20 पे भी करता है, 30 पे भी करता है, 40 पे भी करता है, 50 पे भी करता है, ठीक है. इससे क्या होगा? कौन सा वाला स्टूडेंट इज मच बेटर? इज स्टूडेंट 1 मच बेटर विद देयर प्लानिंग ऑफ इन्वेस्टिगेशन और स्टूडेंट 2 मच बेटर? Yes. Which student is much better? 2 is much better. Yes. Okay. So 2, the student number 2 is basically allowing himself to have a good analysis and to draw much better valid conclusions by repeating their experiments. Okay. And let's suppose if you are repeating experiments and there is some other experiment and you have a whole temperature interval and you're taking a temperature interval from 10 to 50. Okay. So for every the experiment that they are looking into is how much volume of gas is produced at after 10 degree Celsius interval. Okay, so 10, 20, 30 वो measure कर रहे हैं volume of gas after 10 degree Celsius. एक और स्टूडेंट है वो मेजर करता है आफ्टर 5 डिग्री सेल्सियस, ठीक है. तो आफ्टर 10, आफ्टर 15, आफ्टर देन 20, देन 25, देन 30, देन उसके पास ज्यादा इंटरवल्स होगा, सही. उसके पास ज्यादा रिपीटेड वैल्यूज होगी. जितनी ज्यादा आपके पास रिपीटेड वैल्यूज होंगी, जितनी ज्यादा रेपिटेशंस होंगी, आपके रिजल्ट्स कितने ज्यादा, उतने ज्यादा जो है ना वो आपके रिलायबल रिजल्ट्स होंगे, ठीक है. आपके कंक्लूजन्स विल बी मच मोर वैलिड. ओके, they'll be much more precise, they'll be much more nearer to the accurate one, okay, allowing you to even eliminate any of those choices which are inappropriate or they are invalid, okay. तो suitable range की हमने बात कर ली कि आपके results का suitable range क्या होना चाहिए. How can I be sure my results they are accurate or not? By using accurate pieces of apparatuses, by using clear investigations, by using clear methods. Okay, how can I choose? How I have I chosen an appropriate scale of quantities without being wasteful or unsafe? ठीक है, इसके पे भी हमने discussion कर ली. ठीक है, so your whole experimental method is basically designed or should be designed in a way to look into or spot any mistakes and to give any improvements. आपके ऊपर इसके ऊपर भी क्वेश्चन हो सकता है. एक डायमेंशन ये भी हो सकती है जिसके अंदर एग्जामिनर आपसे पूछे कि आप जो है वो बताएं कि आपका एक्सपेरिमेंट जो है वो is it better or not? Would you like to change any pieces of apparatuses? Then you have to go over the diagrams again and again, reread the whole context of the question. तो आपको ज्यादा बेहतर समझ में आना शुरू होगा कि कौन सा apparatus आपको यूज करना चाहिए था और कौन सा apparatus आपको यूज नहीं. ठीक है, अच्छा अब इस पे आ जाते हैं कि ओके सो all right, after looking into the planning of your investigation, then you have certain terminologies. These terminologies, they should be clearer to you by now. Solvent, आपको पता है solvent क्या होता है? Solvent is basically a liquid in which your solute is going to dissolve. So for example, water in sea water is your solvent. Solute is a substance which you are dissolving in a liquid. It is a solid substance or powdered substance which you are going to dissolve in a particular solution. Solution is the mixture which is formed when solute and the solvent, both of them, they're going to dissolve. Saturated solution is that solution which has greater concentration of basically your solute in a limited or in a known volume of the solvent, but at a given temperature. What happens to the solubility? Solubility और temperature का भी relation आपको पता होना चाहिए कि solubility is directly related to each other, related to temperature. Okay, if you are increasing the temperature, solubility is also going to increase. ठीक है, और अगर आप decrease कर रहे हैं temperature को, you cooling down a solution, the solubility is also going to increase. ठीक है, a soluble substance is the one which is going to dissolve in a particular solvent. Insoluble substance is the one which is not going to dissolve in a solvent. For example, sand is insoluble in water, salt is soluble in water. Filtrate आपके पास वो solution होता है जो filter होने के बाद आपको you're going to collect, और residue वो substance होता है which you basically going to collect within the filtering funnel, which is basically the insoluble substance. Okay. Next, we're going to look into the acid-base titrations. Acid-base titrations are methods which are going to analyze the concentration of the solutions. इसके ऊपर हम काफी लंबी discussions कर चुके हैं. ठीक है, इसको बस आप लोग एक दफा रिव्यू कर लिएगा. इसमें कोई ऐसी चीज नहीं है, इसको मैंने क्लासेस में बहुत काफी ज्यादा वो करा है. अच्छा, एंड पॉइंट पता होना चाहिए आपको. एंड पॉइंट बेसिकली इज दैट पॉइंट ऑफ टाइट्रेशन वेयर your amount of volume of the acid or or whatever is present in the burette is going to completely neutralize your solution which is present within the conical class. So it is going to completely neutralize this, as a result of which the concentrations of the hydrogen ions and the hydroxide ions within this solution completely is going to be equal, okay, to each other. So सबसे पहले आप क्या लेते हैं? हमेशा रफ टाइटर लेते हैं. और रफ टाइटल लेने की वजह क्या होती है? रफ टाइटल लेने की वजह ये होती है कि आपको पता चल जाए कि आपने अप्रोक्सीमेटली कितना वॉल्यूम डालना है, क्योंकि आप फिर ड्रॉप वाइज वॉल्यूम ऐड करते हैं. ठीक है, जब आप ड्रॉप वाइज वॉल्यूम ऐड करते हैं फ्रॉम द ब्यूरेट, you allow yourself not to add in any excess volume, and adding any excess volume to the conical flask will basically cause any inaccurate results. ठीक है, आप एक्सेस ऐड कर देंगे और फिर एक्सेस ऐड करने के बाद आपकी सारी रीडिंग्स क्या हो जाएंगी? खराब हो जाएंगी. ठीक है, सो वी डोंट वांट दैट. Then what are the common errors which are seen during a titration? If you don't remove the funnel from the burette, जो हमने अभी शुरू में बात करी थी, ठीक है, this is going to give you any false readings. क्यों? क्योंकि liquid will be dripping into the burette again. Not filling the jet space of the burette. What is the jet space of the burette? जब आप रफ टाइटल लेते हैं तो रफ टाइटल लेने की एक और वजह ये होती है कि आप 0 तक फिल करते हैं पहले तो अपना ब्यूरेट. ठीक है, आपने ये फनल से फिल कर दिया, फनल आपने रिमूव कर दिया, ठीक है। अब आपका ये नॉब के बाद, ये जो नॉब है इसके बाद जो ये पूरा आपके पास नीचे वाला स्पेस है ना, इसको आप कहते हैं जेट स्पेस, ठीक है, ऑफ द ब्यूरेट। इसको भी आपने फिल करना है, तो इसलिए हम रफ टाइटर लेते हैं, ताकि एक जब हम फ्लो कर देते हैं लिक्विड को, तो लिक्विड यहाँ से फ्लो हो जाता है और फिर वो यहाँ पे आके एंड करता है, ठीक है। So we also utilize this whole space. This is basically the space after the part of the burette which is after the tap. So filling this space is also going to give you much better readings and much more accurate readings. Okay, and you always have to start reading from the top. This is going to be your initial reading, और final reading ज़ाहिर है यहाँ से अगर आपके पास ड्रॉप कर रहा है वॉल्यूम, तो ये आपकी इनिशियल रीडिंग है, ये फाइनल रीडिंग आपके पास यहाँ पर होगी, तो ये डिफरेंस ऑफ वॉल्यूम आपने रीड करना है, ठीक है। अच्छा, let's take a 5 minutes break right now. Have some water, go walk around, and then we're going to continue with this one in after inshallah 5 minutes. Okay, I am having 5:10 here at my place right now, so at 5:15 we're going to start inshallah. Okay, 5 minutes break. Okay, yes. Are you all there?
Yes, miss.
Okay. All right. So you are basically discussing about the indicators. All right. So titration आपकी यहाँ पे हो गई. Indicators जो है वो you have to use according to their endpoint titration. Okay. And usually questions which are basically asked in your papers, they ask you which indicator is the most suitable one and what are the colors, the color changes of these indicators. So you should remember litmus solution is going to stay red in acids, they are going to turn to blue in alkalis, and in neutral they are completely purple. Okay, red litmus paper obviously is going to stay red in the acids, it will turn blue, and blue litmus paper is going to stay blue within the alkalis. Okay, and there's no change in. And methyl orange stays red in acid, it is yellow in alkalis, and it in neutral, it is completely at pH 7, it is completely orange. Phenolphthalein is colorless. Thymophthalene is also colorless. Thymophthalene in alkalis is blue, and phenolphthalein is pink. And in neutral, it is completely colorless. So this you have to memorize. Moving on to separation techniques now. Acha, separation techniques, we have discussed this in papers as well. Paper chromatography is conducted to separate substances and to identify and to give information about a particular unknown substance. Okay, so your unknown substance will obviously be a mixture, right? Let's suppose you have a mixture of an ink and it has different dyes in it. Okay, it is a sample of um, 4 to 5 dyes. Okay, so different dyes, they are added to make up a mixture, and if you want to know what dyes are present in it, you are going to compare the RF values. What are the RF values? They're basically the retention factor values of different dyes which are present within that mixture of ink through this process of paper chromatography. So you set up your chromatography paper. Okay, how do you set up a chromatography paper? You use that paper chromatogram. You draw a pencil line. And why do you draw this line with a pencil? Why not with an ink?
Ma'am, it will interfere in the experiment.
It is going to interfere with your results. Okay, so
Yes.
your conclusions will become completely invalid. Okay, and your reference line or your baseline, यहाँ से आप हमेशा measure करते हैं अपना distance of the solute which has been traveled, or your distance of the solvent which has been traveled. This line has to be approximately 2 centimeters above the base of the paper. ठीक है, let's suppose ये आपका base of paper है, ये आपने लाइन जो ड्रॉ करनी है वो एटलीस्ट 2 सेंटीमीटर अबव द बेस ऑफ द पेपर आपने ड्रॉ करनी है. और आपका जो सॉल्वेंट होगा वो 1 सेंटीमीटर तक डिप होगा. ठीक है, so 1 centimeter of the paper has to be dipped into the solvent, and then this solvent has to be below your baseline. It must not be above than the baseline. Okay, it should be always below than the baseline. This solvent is then going to travel upwards, and then it is going to separate all the inks which are all the dyes which are present, or the components which are present within this unknown sample of the mixture. It is going to separate all those inks, all the components, all those separate spots will be formed, and then you can correlate it with the actual dyes, or your actual spots, and then you're going to analyze them. So let's suppose that if you have this brown ink gives you this spot, red, yellow, and blue. So the blue spot aligns with the blue one. Okay, it is going to be in the same line. जो चीज उसके same line के अंदर होगी, इसका मतलब है कि वो substance या वो component इसके अंदर इस brown ink के अंदर मौजूद है. तो अगर मैं आपसे पूछूं कि ये brown ink के अंदर जो है कौन से substance या कौन से components हैं, तो आपका आंसर क्या होगा कि इसके अंदर रेड भी है, इसमें ब्लू भी है, इसमें येलो भी है. ठीक है, क्योंकि ये अलाइन कर रहा है इन सारे स्पॉट्स के साथ, इन सारे नॉन स्पॉट्स के साथ. ठीक है, अच्छा, अगर आपने इसकी RF वैल्यू कैलकुलेट करनी है, तो आप इसकी RF वैल्यू कैसे कैलकुलेट करते हैं? द डिस्टेंस व्हिच इज ट्रैवल्ड बाय द सॉल्यूट. सो बेस लाइन से लेकर यहाँ तक का डिस्टेंस. ठीक है, that the distance which has been traveled by the solute divided by the distance which has been traveled by the solvent. अगर examiner आपको scale से ruler से इसको read करने को कहता है तो फिर you have to use a ruler and then it should be accurate measurements from the ruler as well, okay, to find out the RF value. RF value आपकी कभी भी 1 से ज्यादा नहीं होगी, it is always going to be less than 1, ठीक है, क्योंकि जो डिस्टेंस है जो सॉल्यूट ट्रैवल करता है वो सॉल्वेंट से ज्यादा कभी भी ट्रैवल नहीं करेगा, ठीक है, तो इसलिए आपकी आरएफ वैल्यू हमेशा लेस देन 1 होगी। अगर आपकी आरएफ वैल्यू ग्रेटर देन 1 आ रही है तो इसका मतलब आपका आंसर रॉन्ग है, ठीक है, आपका आंसर क्या है, कंप्लीटली इनकरेक्ट है, यू हैव टू रीचेक योर आंसर अगेन। अच्छा, नेक्स्ट अप द solubility. If let's suppose if I ask you which one out of these is the most soluble, so most soluble is the one which is going to travel the furthest away from your baseline, okay, which means that it is completely more soluble in this solvent, and the one which is traveling less further away from the baseline is the one which is least soluble in this solvent, okay. The amount of components basically tells you that how many components are present within this mixture. Let's suppose if a dye only gives you one spot, this means that it is a pure dye. If it gives you multiple, more than one spots, this is an impure dye. So you can also conclude about purity and impurity of a particular substance, okay. If you have any other amino acids, okay, amino acids or sugars, they are completely colorless, okay. So these are colorless substances, and for these colorless substances, you have to use a locating agent to see these spots. क्योंकि इनके components separate तो हो जाते हैं, लेकिन क्योंकि ये colorless होते हैं तो आपको नजर नहीं आते, ठीक है. So how are you going to make these spots visible? You're going to use a locating agent. Locating agents such as ninhydrin sprays or other locating agents that are used to let me just write it down here. So okay, so it is ninhydrin sprays. These are your locating agents, okay, which you can use to locate these substances, such as specifically for amino acids and sugars. All right, so to make it visible, because ये colorless spots होते हैं, आपको नहीं, they are not visible through a naked eye. So RF value is the distance which is moved by the substance divided by the solvent. आप इसको ruler से measure करोगे और उसके बाद फिर you're going to compare it with any values जो आपके पास किसी उसमें मौजूद होगी, जो आपके ऑलरेडी नोन डाटा बुकलेट के अंदर हो, ठीक है. By comparing it with the known RF values, you will be able to analyze which substances are these. All right. Next up is in your separation and purification techniques is your filtration. Filtration is a method where you are simply filtering out a mixture of solid and a liquid, ठीक है, or a solute and a solvent. If this solute is an insoluble solute or an insoluble solid, तो फिर आप जो है ना इसको filter out करोगे. जो चीज filter out हो जाती है, जो आपकी insoluble solid होती है, उसको residue कहते हैं. And the solvent or the solution which is collected within the beaker here is going to be your filtrate. So इसको याद रखें. Insoluble solid और liquid को अगर आपने separate करना है तो फिर you are going to use the method of filtration. Okay. Other than filtration, there are centrifugation which is used, or decanting which can also be used, like for decanting any sand and water. Okay. Then you have crystallization. Crystallization, you know it by far. Crystallization is where you have a dissolved solid. अब आपके पास ऐसा solid है जो कि soluble है completely and it has formed a solution. तो उसको अगर उसमें से आपको water नहीं चाहिए और आपको सिर्फ और सिर्फ ये solid चाहिए, तो आप इसके salt crystals बना लेंगे, और इसके लिए you are going to use the method of crystallization. What is simple distillation? Simple distillation is when you have a completely you have a soluble liquid solid, और आपको इसके अंदर दोनों चीजें चाहिए. अब आपको water भी चाहिए है और आपको soluble solid भी चाहिए, तो फिर आप क्या यूज करोगे? आप यूज करोगे simple distillation. All right, this is your condenser, which is also referred to as your Liebig condenser. जो आपके simple distillation का जो method है वो for दो substances भी है जो कि जिनके boiling points काफी varying है, ठीक है, where the boiling points they are not so close together. All right, so you can use the method of simple distillation. Fractional distillation is used for any of those substances which are completely miscible. Those liquids which are miscible. Miscible का मतलब होता है the ones which are which can be intermixed within each other. Okay, जैसे water और ethanol को का solution completely बन सकता है. अब आप इसमें separate कैसे करेंगे दोनों को? तो आप इसको सिर्फ boiling point से separate कर सकते हैं. इसलिए you're going to use the method of fractional distillation because this uses this method particularly uses the method of variable boiling points, as a result of which you can get your both of the liquids, okay, both your alcohol as well and your water as well. Up till now, do we have any questions? Yes, up till now, do we have any questions by far? Zoya, Ibrahim, Ayan, Ayla. Okay, chale, next question. Next, if you look into this one is, you have a student who is given a mixture of calcium sulfate and magnesium chloride and water. अब calcium sulfate क्या है? Soluble है, insoluble है? उन्होंने बताया insoluble solid है. Magnesium chloride is a soluble, it's soluble in water and it is a solid at room temperature. How does the student obtain magnesium chloride crystals from the mixture? So these are the four options which are given to you. Is he going to use crystallization and then he's going to use distillation, or he's going to crystallize first and then he's going to use filtration? Yeah, but he's going to use distillation first, then crystallization, or filtration first and then crystallization. We want to obtain magnesium chloride crystals from the mixture. Yes. Yes, what are you going to do? Ibrahim, Ayla, Zoya, and Ayan. देखें, अगर आप पहले आपके पास जो भी इनसॉल्युबल चीज है ना, और आपके पास जो है वो दूसरी चीज है वो सॉल्युबल है, तो पहले आप इनसॉल्युबल को रिमूव करें. ठीक है, इनसॉल्युबल को रिमूव करने के लिए हमारे पास कौन सा मेथड था? फिल्ट्रेशन. तो यू गोइंग टू फर्स्ट फिल्टर इट आउट. ओके, सो फर्स्ट शुड बी अ फिल्ट्रेशन. अब फिल्टर करने के बाद आपके पास क्या बच गया? आपके पास बच गया मैग्नीशियम क्लोराइड विच इज डिसॉल्व्ड इन वाटर. अब आपको मैग्नीशियम क्लोराइड के क्रिस्टल्स चाहिए तो फिर आप क्रिस्टलाइज कर दें, क्योंकि क्रिस्टल्स आपको चाहिए. ठीक है, यू डोंट वांट वाटर. इफ यू वांट मैग्नीशियम क्लोराइड एज वेल एंड एज वेल एज दैट यू वांट वाटर, तो फिर आप फिल्टर करने के बाद क्या करते हैं? डिस्टिलेशन करते हैं. इज दिस पॉइंट क्लियर? सो step method number 4 is the best method choice. Yes, are we clear? Okay, moving on to assessing the purity. Purity is basically assessed by looking into the melting and the boiling points. ये physical method है to use purity of a substance. If a substance is completely pure, it is going to have a fixed or a sharp melting or a boiling point. If a substance is not pure, its melting point is going to differ. Okay. अच्छा, ये आपको पता होना चाहिए कि बॉइलिंग पॉइंट जो है, अगर कोई चीज इम्प्योर है, उसमें कोई भी इम्प्योरिटी है, तो बॉइलिंग पॉइंट हमेशा जो है वो बढ़ जाएगा उसके एक्चुअल बॉइलिंग पॉइंट से, और मेल्टिंग पॉइंट हमेशा जो है वो उससे कम होगा उसके एक्चुअल मेल्टिंग पॉइंट्स. ठीक है, लेकिन रेंज ऑफ मेल्टिंग पॉइंट्स और बॉइलिंग पॉइंट्स भी शो करते हैं कि ये इसमें कोई ना कोई इम्प्योरिटी प्रेजेंट है. नेक्स्ट यू हैव आइडेंटिफिकेशंस ऑफ आयंस एंड गैसेस. इसके ऊपर हम डिस्कशन बहुत सारी कर चुके हैं. इसके ऊपर बस आप ये आपने इसके अंदर सिर्फ मेमोराइज करना है और कुछ भी नहीं करना है. ठीक है, ये पूरे नोट्स मैं आपको दे दूंगी, तो इसको जब आप एक दफा गो थ्रू कर लिएगा. लाइम वाटर का जो हम टेस्ट करते हैं वो बेसिकली किस लिए करते हैं? क्योंकि इसके अंदर कार्बोनेट आयंस होते हैं, दे रिएक्ट विद द एसिड, दे आर गोइंग टू प्रोड्यूस कार्बन डाइऑक्साइड. ये जो कार्बन डाइऑक्साइड होती है वो लाइम वाटर के साथ रिएक्ट करती है. लाइम वाटर क्या है आपके पास? कैल्शियम एक्वस कैल्शियम हाइड्रोक्साइड है. वो जब इसके साथ रिएक्ट करती है तो क्लाउडी सस्पेंशन बनता है. वो क्लाउडी सस्पेंशन क्यों बनता है? मिल्की सस्पेंशन क्यों बनता है? क्योंकि कैल्शियम कार्बोनेट इज प्रोड्यूस्ड एज अ रिजल्ट एंड वाटर इज आल्सो प्रोड्यूस्ड. So this calcium carbonate is basically the cloudy suspension which is produced here in this case scenario, right? So these colors you have to remember: AgCl, white, bromide, cream color, yellow colored precipitates because of iodide. ठीक है, बेरियम सल्फेट आपके पास क्या होता है? white in color होता है. So remember all of these things. अच्छा, next you have ammonium. Ammonium and ions, they are NH4 plus. Ammonia gas is produced when they react with your sodium hydroxide aqueous to produce ammonia gas, which is basically weakly alkaline color. So this is the whole summarized table of this one. और ये आपको जो है वो papers में भी given है. So you can use that as well. Next up is your flame test. Flame tests, they're basically used to identify the metal cations by the colors of the flame. और जो इनके flame colors होते हैं उससे you are able to identify what metal cation is basically present. Now, how do we conduct a flame test? We basically use a loop of a nichrome wire. Nichrome wire is used या फिर platinum wire is used to make a wire loop. और ये basically unreactive metal होता है, उसको हम फिर dip करते हैं किसी concentrated acid के अंदर ताकि कोई भी impurities हैं तो वो remove हो जाए. फिर then you are going to hold it in the blue flame of the Bunsen burner until there is going to be no color change. This step is very important so that you are able to only identify only one particular type of an ion और कोई भी identification के अंदर आपका error ना हो. और आप इस तरह से जो है वो wire loop को भी clean कर देते हैं and you basically avoid your contamination as well. Then you are going to dip this loop of wire into the sample or the solution and then again place that edge of the loop, not the whole metal wire loop, only the edge of it onto your blue Bunsen flame. Okay, this is going to allow your Bunsen flame to allow this wire to not get too much hot. Otherwise, if it gets too much hot, then it is going to become this whole metal wire loop. क्या हो जाता है जब जितना ज्यादा वो रेड होगा उतना ज्यादा वो क्या हो जाएगा, ऑरेंजिश हो जाएगा, ऑरेंजिश रेड हो जाएगा पूरा वायर लूप. और अगर वो ऑरेंजिश रेड हो जाएगा तो आपका फ्लेम कलर क्या होगा, इट इज गोइंग टू डिफर. So these are the flame colors that you get. Lithium, with lithium it is red color, sodium is yellow, potassium is purple, lilac basically, and your calcium is orange red, your barium is light green, and your copper is blue green in color. Okay. And your sample must be heated strongly ताकि आपका जो Bunsen burner का जो flame है वो जो है वो एक blue flame ही रहे. ठीक है. These are all your tests for gases. ये हम discuss कर चुके हैं. So any questions? Do we have any questions by far? Yes, any questions by far? What is the test for water? The chemical test for water? There are two tests of water. One is a physical test, the other one is a chemical test. If the examiner says what is the physical test of water, you have to tell and exhibit your knowledge of physical test, that is the boiling point or the melting point. Okay? But let's say they talk about the test of presence of water. This means they're talking about the chemical test of water. So whether this water is pure water or this is impure water, then that is tested with anhydrous cobalt chloride paper or anhydrous copper 2 sulfate. Anhydrous cobalt 2 chloride is blue in color, and if that paper is dipped into the water, if it is pure water, it is going to change its color from blue to pink. Yes, is this clear? Okay, pH test. Ayla, what are you talking about? I didn't get you. I'm sharing another screen with you. एक चीज मुझे आपसे और डिस्कस करनी है। अच्छा, अब आपने एक काम ये करना है कि आपने पूरा सिलेबस गो थ्रू करना है और हर टॉपिक से distilled water is distilled water or deionized water, that is neutral completely, and that is pH 7. Okay, अच्छा, अब आपने काम ये करना है कि that you're going to look into complete syllabus, ठीक है, और कंप्लीट सिलेबस में जो आपके प्रैक्टिकल एनालिसिस है वो मैं आपको बता देती हूँ किस किस टॉपिक से आएगा, ठीक है, जो पोटेंशियली कहाँ कहाँ से आपको प्रिपेयर करना चाहिए है, ठीक है। यू हैव टू प्रिपेयर फॉर मोल्स, okay, and stoichiometry, which is used in your acid base titration. Electrolysis के ऊपर आपको पता होना चाहिए, endothermic exothermic reactions या chemical changes, ठीक है, rate of reaction, reversible reactions, and chemical equilibrium. Rate of reaction और salt preparation ये तो ऐसी चीज है कि आपने करनी ही करनी है, no matter what, ठीक है। acid base titration ये भी आपने लाजमी करनी ही करनी है। मेटल्स के ऊपर से सवाल क्या आ सकता है प्रैक्टिकल्स में, पेपर 6 में, के रिएक्टिविटी सीरीज के ऊपर, कि which metal is more reactive, which one is less reactive, सही है, या फिर ऑर्डर ऑफ रिएक्टिविटी निकालें। अब ऑर्डर ऑफ रिएक्टिविटी कैसे चेक करते हैं, जो मेटल आपने डिप किया और जिसके जो है जिस मेटल के ज्यादा बबल्स ऑफ हाइड्रोजन गैस प्रोड्यूस हुए या ज्यादा बबल्स ऑफ गैस प्रोड्यूस हुए इन द सेम अमाउंट ऑफ टाइम, ठीक है, तो इसका मतलब है वो ज्यादा रिएक्टिव है। जिसके कम प्रोड्यूस हो या जिसके बिल्कुल भी प्रोड्यूस नहीं हुए तो वो तो बिल्कुल ही अनरिएक्टिव है, लेस रिएक्टिव, लीस्ट रिएक्टिव, नाइव मेटल है, ठीक है। मैं आपको कुछ वर्कशीट्स भेजूंगी व्हाट्सएप पे आप लोग के ग्रुप पे, तो उस पे जो है वो आप लोग को वर्कशीट जो है वो डेली अलॉट कर लें कि आप उन्हें वो वर्कशीट जो है वो सॉल्व करनी है, और फिर उसके बाद अगर आपको उसमें कोई भी क्वेश्चंस हो तो फिर यू गोइंग टू आस्क, ठीक है, रिगार्डिंग टू योर पेपर 6। पेपर 6 आप लोगों का कब है? व्हेन इज योर पेपर 6? 15th में? इज इट 15th of May? First paper I think is your paper 4, which is 30th of April.
Yes, ma'am. मेरा है yes 15th में.
15th में. Everybody has the paper on 15th, paper 6.
Yes.
ठीक है, तो आपके पास अभी approximately one whole month you have to go through those worksheets, ठीक है, और साथ में जो है वो अगर आपको उसमें कोई भी क्वेश्चंस होते हैं you can definitely ask me, ठीक है। अच्छा, मैं आपसे एक और डिस्कस करनी है। तो जब आप हर क्वेश्चंस हर टॉपिक के उसको देखेंगे तो फिर आपको जो है ना हर डायमेंशन से आप लोग कवर कर पाएंगे। जब जितनी ज्यादा डायमेंशन आप कवर करेंगे अपने एग्जाम के लिए, इट इज गोइंग टू बी मच मच बेटर फॉर यू। ओके, सो जस्ट अ मिनट। Also, whenever you're solving questions at home, this is for generally for all the papers that you're doing. So time your papers, okay? Once you're going to start timing your papers, you will get to know that and you will be much good at time management, ठीक है। आपको पता चलेगा कि आप अपने क्वेश्चन जो है वो टाइमली कर पा रहे हैं या नहीं कर पा रहे, ठीक है, और कितना टाइम आपको जो है वो देना चाहिए हर क्वेश्चन के लिए, बिकॉज आपका ये पेपर जो है वो इट्स गोइंग टू बी 1 hour मैक्स, ठीक है। 1 आवर का आपका ये पेपर होता है, इसमें इतना ज़्यादा आपने हर क्वेश्चन के ऊपर, और ये बिल्कुल स्ट्रेट फॉरवर्ड क्वेश्चन है, इसमें कोई ऐसे सवाल होता ही नहीं है आपके पास जिसमें बस एनालिसिस वाले क्वेश्चन होते हैं आपके पास, ठीक है। तो इसमें ऐसी कोई चीज़ नहीं है कि जो आपको समझ में ना आए। सेफ्टी प्रिकॉशंस, यस, फॉर प्लानिंग, जो हमने फर्स्ट उसमें डिस्कस किया था, सबसे फर्स्ट जो अभी इससे पहले हमने क्लास ली थी, जो कंपनसेटरी सेशन था, जिसमें मैंने सेफ्टी प्रिकॉशंस आपसे डिस्कस, दैट that is also asked. You don't really have to mention the safety precautions until unless it is asked in planning and investigation. Planning and investigation question के अंदर आपको safety precautions नहीं mention करनी until unless it is asked in the paper, ठीक है। अच्छा, look into, let me know if the screen is visible. Yes, is the screen visible?
Yes.
Okay, let's suppose this is your graph, ठीक है। You are given the x-axis, this is your y-axis, ठीक है। x-axis y-axis का आपको पता चल गया, आपने प्लॉट कर लिए अपने रिजल्ट्स, ठीक है। अच्छा, आप जब प्लॉट करोगे अपने रिजल्ट्स, तो आपने या तो एक स्मॉल क्रॉस मेंशन करना है या फिर अ डॉट एंड जस्ट इनसर्कल इट, ओके। So either of these two you can use. You have plotted all your recorded results and the data, and you are asked to draw a line of best fit, let's suppose, okay. So a line of best fit is basically the line which starts from origin, okay, and it has to go through maximum points, okay. It has to go through a maximum points. ये बहुत सी line नहीं, but I can take, yeah, okay. So the one which is going to go through maximum points, that is going to be your line of best fit, ठीक है। अब इसके अंदर, इस पूरे उसके अंदर अगर कोई एक recorded result था जो कि which is too far away from your actual trend, this is going to be referred to as your anomalous result. और anomalous result क्यों होते हैं? जब आपके पास या तो आपकी method of investigation, your experimental design is incorrect, आपने कोई इनकरेक्ट वैल्यू ली होती है, इनवैलिड आपका रिजल्ट होता है, इनएक्यूरेट आपने रिजल्ट्स लिए होते हैं, या फिर आपका एपरेटस इनएक्यूरेट होता है, कोई टेक्निकल आपका कोई एरर होगा, या फिर ह्यूमन ऑब्जर्वर रिलेटेड एरर होगा, या फिर आपका एक्सपेरिमेंटल डिजाइन इनकरेक्ट है, ठीक है। तो फिर आपके पास ये एनॉमलस रिजल्ट्स आते हैं। बाकी बेस्ट फिट लाइन जब भी आपसे पूछा जाए या बेस्ट फिट कर्व पूछा जाए, तो वो इसी तरीके से होगा जिसमें मोस्ट ऑफ द पॉइंट्स दे आइदर लाई और देयर आर नियरर टू योर बेस्ट फिट लाइन, ठीक है। अगर बेस्ट फिट कर्व कहेंगे वो, तो फिर इसी तरीके से आपने वो ड्रॉ करना है बेस्ट फिट कर्व, इस तरीके से, सही है, जिसके अंदर आपके मोस्ट ऑफ द पॉइंट्स दे आर गोइंग टू बी आइदर नियरर टू इट और ऑन टू योर एक्चुअल कर्व, ओके। आपने डॉट्स नहीं ज्वाइन करने, ठीक है। अगर फॉर एग्जाम्पल ये आपका कर्व है, तो आपने ये डॉट्स नहीं ज्वाइन करने इस तरह से, इस तरह से, ये गलत है। Is this point clear so far?
Yes.
Okay. Another question which is usually asked, Zoya, may I be leading questions? If there is another question which is usually asked in the paper, क्या चीज के आपसे पूछा जाता है कि draw or mention or plot the results on the grid and draw a smooth line of graph और आपको बोला जाता है कि आपने मेंशन करना है स्केल, ठीक है। तो आपने स्केल जो है वो अपने इंटरवल्स के हिसाब से मेंशन करना है, सही है। मैं जैसे आपसे शेयर कर रही हूँ स्क्रीन, let me know once the screen is visible. Is the screen visible? अब देखें, इसमें आपके साथ आपके पास जो पीएच वैल्यूज उन्होंने मेंशन की हैं, वॉल्यूम ऑफ हाइड्रोक्साइड इज इन रेगुलर इंटरवल्स, ठीक है। पहले 5 है, फिर 10 है, फिर 15 है, फिर 20 है, फिर 24.5। इसका मतलब नेक्स्ट आपकी वैल्यू जो आनी चाहिए वो 25 तक आनी चाहिए, ठीक है। फिर आपके पास जो है वो 30, फिर 35, फिर उसके बाद 40 आपका मैक्सिमम इंटरवल है। तो आपका जो रेंज है इंडिपेंडेंट वेरिएबल की, आप वॉल्यूम ऑफ हाइड्रोक्साइड चेंज कर रहे हैं और पीएच वैल्यू आप जो है वो रीड कर रहे हैं। तो आपका जो इंडिपेंडेंट स्केल है वो 0 से लेकर कहाँ तक जाएगा, 40 तक जाएगा। अब आपका जो पीएच वैल्यू है वो कहाँ से जाएगी, वो भी 0 से ही स्टार्ट होगी और ये कहाँ तक जाएगी, मैक्सिमम 14 तक जाएगी। तो आपने पीएच स्केल जो अपना लेना है वो क्या लेना है, 0, फिर 2, फिर 4, फिर 6, फिर 8, फिर 10, फिर इसी तरह से पूरा टोटल 14 तक, ठीक है। आपका पीएच वैल्यू कहाँ पे, ऑन योर वाई एक्सिस, क्योंकि ये आपका डिपेंडेंट वेरिएबल था। और वॉल्यूम ऑफ हाइड्रोक्साइड आप चेंज कर रहे थे, तो फिर ये आपका क्या हो जाएगा, एक्स एक्सिस के ऊपर हो जाएगा। इज दिस पॉइंट क्लियर? तो अगर आप ये नेक्स्ट ग्राफ देखें, ये ग्रिड अगर आप देखें, तो ये पीएच का जो स्केल होगा वो आपका इस तरीके से ड्रॉ होगा, 0 से लेकर 14 तक, और इसी तरीके से यहाँ 0 विच इज गोइंग टू बी योर रीजन टिल 40 सेंटीमीटर क्यूब आपका मैक्सिमम क्या है, हाइड्रोक्साइड है। यस जोया।
Miss, if the question has not mentioned to draw a line of best fit, then do we or do we not?
You still draw the line of best fit. Let's suppose, so what is the question? So tell me the question. What does the examiner say? What is it mentioned? Just draw a straight line. Does it say draw a straight line?
Like, for example, the graph that you were showing about, it did not mention whether we have to draw a line of best fit or not.
नहीं, तो भी आपने बेस्ट फिट लाइन ही ड्रॉ करनी, ठीक है। तो भी आपने बेस्ट फिट लाइन ही ड्रॉ करनी है, डोंट हैव टू जॉइन ऑल द डॉट्स, ओके।
Okay.
मिस,
जी जी।
हमारा भी ऑल्टरनेटिव प्रैक्टिकल पेपर के अंदर यही आया था कि हमें ड्रॉ द लाइन ऑफ बेस्ट फिट करनी थी, और हमने वही की हमारी सारी क्लास ने। मगर फिर हमने एमएस चेक किया तो लिखा होता आपने कर्व बनाना था, हालांकि कर्व का कुछ मेंशन नहीं किया होता।
वापस से बोले, मुझे आपकी आवाज जो है वो बहुत डिस्टॉर्ट हो रही है, वॉइस। mention your question in the chat box. एक आप कह रहे हैं वेरिएंट सॉल्व किया है, फिर क्या किया है, समझ में नहीं आया मुझे। Is this screen visible? Yes, is the screen visible? Yes, is the PowerPoint visible to everyone? Okay. अच्छा, अब इसमें आपसे थोड़ी सी चीजें डिस्कस करनी है। पहली चीज ये कि आप जो है वो अपना टाइम मैनेजमेंट बहुत ज्यादा क्रूशियल है। यू हैव टू एलोकेट अ पर्टिकुलर टाइम फॉर योर होल सेक्शन ऑफ द पेपर. At least leave 5 to 7 minutes or at least 10 minutes for your paper to review at the end. 7 minutes आपके पास लाजमी एंड में होने चाहिए, और जब तक आप ये अपने पास पेपर्स को प्रैक्टिस नहीं करेंगे, you will not be able to achieve a good रिजल्ट, जो डिजायर्ड आउटकम है, ठीक है। जितना हम ये एफर्ट्स डाल रहे हैं, दिस इज टू मच रिक्वायर्ड, ठीक है, दैट यू प्रैक्टिस मच एंड मोर. जितना ज्यादा आप प्रैक्टिस करेंगे यू गोइंग टू इवेलुएट योर होल सेल्फ, ठीक है. एंड यू कैन ऑल्सो सेंड मी योर क्वेश्चंस personally as in the DMs or in the group as well. I'll look into those. जब भी आप क्वेश्चन रीड करें, ये मैं जनरल आपको बता रही हूँ, फॉर योर पेपर 4 एंड योर पेपर 6, ओके. लुक इनटू द कमांड वर्ड्स, ठीक है, कि आपके कमांड वर्ड्स क्या हैं, ठीक है. what is the examiner asking for, what does he say. for instance, अभी भी जब हम past papers हम practice कर रहे हैं, so you are able to identify that what command words are used. Let's suppose the examiner says to define it, or the examiner says to calculate, or the examiner says to determine, to deduce. So you are now able to identify कि command words का क्या मतलब है. जो कोई की टर्म्स हैं आपने उसको जो है ना अंडरलाइन करके, सही है, अपना पेंसिल से आपने उसको अंडरलाइन करके. अच्छा, नंबर ऑफ मार्क्स, दीज आर ऑल्सो वेरी इंपॉर्टेंट टू गिव यू अ गाइडेंस कि आपका आंसर का डेप्थ कितनी होनी चाहिए. लेट्स सपोज आपसे एक क्वेश्चन पूछा गया है कि डिफाइन एन अनसैचुरेटेड हाइड्रोकार्बन, ठीक है, या डिफाइन एन आइसोटोप. So for mentioning, what about the definition for an isotope? It would be either for 2 marks or for 1 marks. Similarly, if the definition for unsaturated hydrocarbon is for 2 marks or 1 mark. तो 2 marks की definition के अंदर आपने you have to completely mention about both the terminologies. You have to mention, you have to define what is unsaturated, what is hydrocarbon, ठीक है. लेकिन let's suppose if it's for 1 mark, so even if you define it completely या फिर you define it in one way, ठीक है, तो भी इट इज मार्क करेक्ट. लेकिन 2 मार्क्स की अगर डेफिनेशन है तो इसका मतलब है कि आपने पूरी कंप्लीट डेफिनेशन मेंशन करनी है. लेकिन इस पे एक टिप है, जब भी आपसे डेफिनेशन पूछी जाएगी, चाहे वो कम मार्क्स की भी हो, लेट्स सपोज इफ इट्स फॉर 1 मार्क्स, तो भी जो है ना आपने कंप्लीट डेफिनेशन मेंशन करनी है, सही है. डायग्राम्स आपको बहुत सारा क्लू देती है, जैसे अभी हमने बहुत सारी जैसे अभी हमने एक क्वेश्चन किया था जिसके अंदर डायग्राम वाज एबल टू हेल्प यू आइडेंटिफाई, इट वाज एबल टू हेल्प यू फैसिलिटेट थ्रू व्हाट द एग्जामिनर इज बेसिकली आस्किंग फॉर, ठीक है. अच्छा, जो प्लानिंग ऑफ इन्वेस्टिगेशन के क्वेश्चंस होते हैं उसके अंदर आपने एक सैम्पल क्वेश्चंस मैंने पहले भी दिए हुए और उसमें आंसर पहले भी दिया हुआ है. उसके अंदर अगर आपने पहले से एक माइंड मैप प्रिपेयर कर लिया तो फिर आपके लिए ज्यादा आसान है उस पूरी इन्वेस्टिगेशन को प्लान करना और फिर उसके बाद जॉट डाउन करना व्हाटएवर इज गिवन टू. केमिस्ट्री में व्हाट इज मच इम्पोर्टेंट, यू हैव टू कन्वर्ट यूनिट्स. अगर आप यूनिट्स, usually units are given to you, but let's suppose if the units are not given to you, you have to mention the units लाजमी. और यूनिट्स के जो है वो मार्क्स होते हैं और कन्वर्जन के मार्क्स होते हैं. तो हर स्टेप जो है वो आपने शो करना है. अगर कैलकुलेशन का कोई स्टेप है आपने शो करना है. इक्वेशंस के अंदर आपने स्टेट सिंबल्स मिस नहीं करने. अगर उन्होंने स्टेट सिंबल्स मेंशन नहीं किया हुआ है, लेट्स सपोज एग्जामिनर डज नॉट मेंशन इंक्लूड स्टेट सिंबल्स, तो फिर आप इसको कर सकते हैं क्योंकि इसमें कोई मार्क्स नहीं है स्टेट सिंबल. लेकिन अगर एग्जामिनर ने कहा है कि इंक्लूड स्टेट सिंबल्स, तो फिर स्टेट सिंबल्स का पूरा 1 मार्क है और आपने मेंशन करना है. सो नेवर फॉरगेट योर स्टेट सिंबल्स. ऑलराइट, any imprecise definitions or any vague answers not using chemical terminologies जो हमने पढ़ी हैं, ठीक है, is going to lead you to not gaining or scoring desired results, ठीक है. एक्सोथर्मिक एंडोथर्मिक को प्लीज कंफ्यूज नहीं करिएगा. इसकी जब भी आप डेल्टा एच की वैल्यूज लिखनी है आपने, तो फिर यू हैव टू मेंशन द साइन, यू हैव टू मेंशन वेदर इट इज पॉजिटिव वैल्यू और अ नेगेटिव वैल्यू. आयंस इन इलेक्ट्रोलिसिस आर वेरी इंपॉर्टेंट. मोल्टन के अंदर कोई हाइड्रोजन हाइड्रोक्साइड आयंस नहीं होते, एक्वस के अंदर हाइड्रोजन हाइड्रोक्साइड आयंस होंगे. डायग्राम्स, ग्राफ्स को प्रॉपर्ली लेबल करना है, ठीक है, अलॉन्ग विद द यूनिट्स. जब आप एक्स एक्सिस के ऊपर ग्राफ को मेंशन करोगे, उसके ऊपर लेबल करोगे कि ये एक्स एक्सिस जो है, लेट्स सपोज इफ इट्स वॉल्यूम ऑफ पोटेशियम हाइड्रोक्साइड, आपने वॉल्यूम ऑफ पोटेशियम हाइड्रोक्साइड मेंशन कर दिया, लेकिन वो वॉल्यूम किस में मेजर कर रहे हैं आप? सेंटीमीटर क्यूब में मेजर कर रहे हैं, डेसीमीटर क्यूब में मेजर कर रहे हैं, मीटर क्यूब में मेजर करना है, वो भी आपने यूनिट्स लिखने हैं ऑन द ग्राफ एज वेल. ओके, सो यू हैव टू मेंशन व्हाट यूनिट्स आर देयर. ऑलराइट, lastly you practice more and more past papers, look into all the syllabus की सारी एक go through करें, कोई skim करें और फिर उसके बाद टिक इट ऑफ कि आपने क्या पढ़ लिया है, क्या नहीं पढ़ लिया है. एक्टिवली रिकॉल करें, शॉर्ट नोट्स बना लें, ठीक है, या फिर यूज माई नोट्स. ऑल ऑफ दीज लेक्चर्स दे विल बी अवेलेबल ऑन योर गूगल ड्राइव एज वेल. उस पर मैं अपलोड कर दूंगी. और डेफिनेशंस फार्मूला को आपने ऐसे याद करना है, स्पेशली ऑर्गेनिक के जो रिएक्शंस हैं उनके फ्लैश कार्ड्स बना लें या एक पेपर ले लें और उसके ऊपर जो है वो शॉर्टली मेंशन कर दें अलॉन्ग विद देयर कंडीशंस. कंडीशंस बहुत इंपॉर्टेंट है, ऑर्गेनिक की कंडीशंस बहुत आती हैं, तो इसको आपने वो करना है और बिल्कुल भी प्रेशर नहीं लेना, ठीक है. तो आपने ये सारी चीजों को जो है वो ध्यान में रखना है जब आप जितना ज्यादा आप प्रैक्टिस करेंगे क्वेश्चंस को, और जब एक पर्टिकुलर क्वेश्चन आपकी नजर से गुजर चुका होगा, तो जब आप उसी तरीके का क्वेश्चन देखते हैं एग्जाम के अंदर तो फिर आपको वो मुश्किल नहीं होगी। ठीक है, तो इसलिए जरूरी है कि आप जो है ज्यादा से ज्यादा पेपर्स प्रैक्टिस करें। अगर आपके पास बहुत टाइम है तो फिर आप जो है वो वेरिएंट्स भी प्रैक्टिस करें, वरना सिर्फ पहला वो वेरिएंट सॉल्व करें जो आपने आपने जिसमें अपेयर होना है। ठीक है, और फिर उसके बाद इफ यू हैव मोर टाइम सो यू कैन गो थ्रू द रेस्ट ऑफ द वेरिएंट्स एज वेल, और पेपर 4 के डिस्क्रिप्टिव क्वेश्चंस को सॉल्व करें, और बाकी जो है वो आपने पेपर 6 सॉल्व करना है। पेपर 6 यू हैव टाइम, पेपर 4 पहले है आपका, तो पहले पेपर 4 पे आपने फोकस करना है। ठीक है, दिस इज गोइंग टू हेल्प यू इन टाइम मैनेजमेंट एज वेल, एंड ऑल्सो structuring your questions as well according to the relevant needs. All right, any questions by far? Do we have any questions up till now? Yes, Zoya.